Hi, welcome. This is Guntuka Srinivas. Welcome to the Varenya's Photon Online Educational Academy for IIT and NEET examinations. This channel mainly focuses on the basic concepts related to the IIT and NEET examinations in the subjects of physics, chemistry, and mathematics. In this session, let us see the chemistry subject. I welcome you all for the IIT chemistry classes. In the previous session, we have seen about the states of matter, that is solid state, liquid state, and the gas state. Let us further discuss the concepts of chemistry. Matter is classified as three types. We have seen solid state. Second is liquid state. Third is gaseous state. Yeah. So these are the three states of the matter: solid, liquid, and the gaseous state. We have also seen about the states in the previous session. In the solids, particles are closely packed, and solids have fixed shape and fixed volume. Whereas in the liquids, particles are loose, but continuity is maintained among the particles. Liquids do not have a definite shape. In whichever container or vessel you pour the liquid, they occupy the shape of that vessel or that container. But liquids possess definite one. Whereas, coming to the cases of the gases, in the gases, particles are very loose. A high freedom is available for the particles for their movement. And gases do not have definite shape, and they do not possess definite volume. Why? Because if you are allowing a gas, there's a small chamber. That gas occupies that space in that small chamber. The same gas is allowed in a big chamber. That gas occupies the entire space of the big chamber because particles have a good freedom for the movement. Hence, the space occupied by the gases according to the chamber in which they are released in. Clear? That is the difference between solid, liquid, and the gases. In the previous session, we have seen that if solids are heated, subjected to heat, they will be converted into the liquids. Further, liquids, if they are subjected to heat, converted into the gases. And observe, these are reversible reactions. These are reversible reactions. If gases are condensed, cooled, then that will be converted into the liquid. If liquids are subjected to freezing, again cool, they will be converted into the solids. This is the fundamental basic equation associated with the solids, liquids, gases conversion. All are reversible. A solid can be converted into the liquid, and a liquid on subjection to the heat can be converted into the gas, and vice versa also possible. Gas, when it is condensed, it will be converted into the liquid, and liquid on freezing, again subjected to cooling, it will be converted to the solid. Here I take up a simple example of the ice. Let us say, I am taking a small ice cube. This is a ice cube in the fridge, the refrigerator. We see the ice cubes. This is an ice cube, which is in the form of solid. This ice cube is in the form of solid shape. When it is subjected to heat, this ice cube will be turned into the water. All this becomes the water. This is water. And this is the liquid stage. This is the liquid stage. Again, when the water is subjected to heat, this water further will be converted into the vapors. That means this is a gas. This is a gas state. Vapor. This is a gas state. So solid is ice cube. Water is liquid. Vapor is in the gas state. Clear? On subjection to the heat. Similarly, if vapor is condensed back, it will be converted into the liquid droplets. Again, if this liquid is freezed, it will be converted into again the crystals of ice. ice cube. Reversible process. Clear? You might have understood. Now, let us see broad classification. That is the classification of matter in the physical state. Classification of the matter in the physical state. Clear? Now let us see the classification of matter, classification matter according to chemical nature, according to the chemical nature. Clear? Solid, liquid, gases, that is the physical classification of the matter. Let us see the classification of matter according to its chemical nature. Clear? Now, observe that matter according to the chemical nature is classified into two types. The first is a mixture. The other is pure substance. Observe carefully this. Matter, according to its broad macroscopic classification, broad classification according to chemical nature, it is subjected into the two types, mixture and pure substance. Pure substance. Here I show you the detailed classification. Matter, first is mixture. The other is pure substance. Pure substance. Mixtures are further classified again into two types. Homogeneous mixtures. Homogeneous mixtures and heterogeneous mixtures. Homogeneous mixtures and heterogeneous mixtures. Yeah. So mixtures are broadly two types. Again, the pure substances are classified into the two types. Elements and compounds. Elements and the compounds. Yes? This is the classification of matter. Okay? Let us see one by one. Let's take up first mixture. What is mixture? What is mixture? This is the basic question that we come across. Clear? Mixture contains many types of particles. Here I write clearly. Mixture contains many types of particles. Mixture contains many types of particles. Clear? And these particles are maybe two or more than two of the pure substance. Clear? The particles yeah, of two or more than two pure substances. Pure substance. Have the clarity in this case. As I said, mixture contains many types of the particles, and these particles either maybe two or more than two. Any number of, more than two means any number of pure substance. That means when two or more pure substances are mixed, two or more than two pure substances are mixed, that is known as the mixture. In other words, I clearly write when two or more than two pure substances are mixed, then that composition is known as mixture. Observe carefully. When two or more than two pure substance, what are these? Pure substance are mixed, then that composition is known as mixture. That means, what does it indicate? The components of mixture are pure substance. The components which are forming the mixture are pure substance. Clear? Here I write the components forming mixture are pure substances. How the clarity. Internal components of the mixture are pure substances. When two or more than two pure substances mix, then that proportion is known as mixture. And observe carefully that in the mixture, the ratio of these pure substances may be variable. It can be anything. So here I clearly write Right? Clearly, right? The composition, the composition is variable. Composition is variable. Okay. And they may be, they may be in any ratio, any ratio. This is very, very important. They may be the pure substances which are forming the mixture composition. It is completely variable and they can be in any ratio. There need not be any fixed ratio. It is always a variable. Clear? Okay. Now, observe. Here, I would like to quote some examples for the mixture. Examples. Observe. A general example we can take up is air. Observe. Composition of air. See, air contains nitrogen. Air contains nitrogen. Air contains oxygen. Air contains carbon dioxide. Air contains argon and many more. Clear? This is the composition of the air. So, hence, we call air as a mixture. So, observe carefully. Nitrogen, oxygen, carbon dioxide, argon, and other elements. Yeah. So, all these are the pure substances which are forming the mixture. And these are in different ratios, and hence we call air as a mixture. Clear? Now, another general example, you can see another example here I quote. You go to a hotel. General simple example I am putting. Mixture. You in hotels. In hotels. Okay. You order for a mixture. You order for a mixture. What he will do? He will mix various components in the mixture and he will give for you to eat. There is a simple example, mixture. And another example here I quote is in our day-to-day life, we prepare tea. We prepare tea. What is a tea? Observe. In what we mix tea? Water. Okay. We pour milk. Okay. We pour tea powder. We go with sugar. So all these are substances which are forming the tea. This is a mixture. Yeah. This is a mixture. And you may be seeing Sometimes, here I quote, sometimes pulses or grains are mixed with uh, mixed with small stone pieces, small stone pieces. Pulses or grains are mixed with small stone pieces. This is also mixture. So all these are pulses. Pulses are the grains, and internally you will be having some stones. This is also example of mixture. In our day-to-day life, we see so many things as mixtures. Clear? Now, here I summarize this. Here I summarize this thing. Mixture contains mix of pure substances. Mix of pure substances. Next, composition of mixture variable. Third, let me take a composition in any ratio, or the components that are forming the mixture, it can be in any ratio. Clear? So examples, we have quoted so many things. These are the salient features of the mixture. Clear? Now, observe. As I told that mixture is further classified into the two types. First one is homogeneous mixture. The second is heterogeneous mixture. The term itself indicates homogeneous means the components are uniformly distributed. Here I clearly write components are uniformly distributed. Yeah, the components are uniformly distributed. That means particles which are forming the mixture are throughout the mixture are consistently, uniformly, they are mixed with each other. That is the meaning of homogeneous uniform mixture. Here, whereas in this case, components are not uniform throughout. hetero. Meaning of hetero is that the homogeneous means all the components, all the particles are consistently homogeneously, means uniformly distributed, thoroughly mixed. Whereas in the heterogeneous, components are not uniform. They are not evenly distributed. Mixture is not uniform throughout. That is the meaning of heterogeneous. Clear? Now, observe carefully. Just now, I told you that examples. Here, example. Homogeneous mixture, air. In the air, all the components, nitrogen, oxygen, they are thoroughly mixed, completely uniformly mixed. Whereas the heterogeneous, just now I told that pulses with stone pieces, You can easily separate the stone pieces by hand picking. They are not properly mixed, not uniform. Whereas in the air, you cannot separate the nitrogen, oxygen. They are uniformly mixed. But in the heterogeneous pulses, stone pieces can be easily separated. So they are not having the uniform throughout. Here, so mixtures, again, we can classify them as homogeneous and heterogeneous. Here, now, when we look up about the mixtures, can be separated. Here I clearly write that the components of mixture can be separated by physical methods. Understand carefully. You can apply for separating the components of mixture. You can separate them by following some physical methods. What are those physical methods? Here I quote number 1, the simple hand picking. Simple hand picking, just now I told you that the stone pieces from the pulses can be easily separated. Example, stone pieces from grains or pulses can be separated by hand. Yeah, you can easily pick out, separate the stone pieces. This is the simplest physical method. Okay, and coming to the second one is filtration. Clear? Whenever you want to separate the components, you can make use of filters by making use of filters. Components of mixture are separated. In our day-to-day life, we see this filtration. Clear? So when you are making a tea, okay, what are the components we are putting it? Water, milk, tea powder, and sugar, etc. And after complete preparation of the tea, what we do? We filter it by means of a sieve. We filter it. So by making use of filters, we separate the tea powder, etc. Clear? The large size particles are simply separated by using the various category of the filters. This is a filtration. Another big. Clear? Now, let us see the third technique, that is crystallization. Crystallization. You can separate these mixtures from this crystallization process. Observe. Salt is made from seawater. Salt is made from sea water. Salt is made from seawater. So, in that, salt crystals are separated out. Clear? Okay. That means you are making the liquid in the form of the crystals on subjection to freezing. You are making the liquids in the form of the crystals, and those crystals are separated out. That is known as crystallization. Crystals will be easily separated. This is another process. The fourth category, if you have physical method, is distillation. Distillation. Observe. Suppose, let us say that you are taking a dirt water. All these are inside particles are dirt particles. Dirt particles are present, and this is water. That means this is a impure water we have taken. Impure water we have taken. And when you are heating it, this is if you are subjecting to the heat. When you are heating it, okay, the water is converted into vapors. Water is converted into vapors, and dirt particles are separated out, and the vapor is further condensed and is converted into the liquid. So carefully, water, dirty water, impure water, when is subjected to heating, all the water, pure water is evaporated, and those vapors are collected, condensed, converted into the liquid. Pure water is separated out, and dirt particles will remain here. This dirt is separated from the water. This is known as distillation process. Clear? Distillation process. Okay. So these are various methods to separate out the components of mixture. Simple hand picking, crystallization, filtration, and also distillation. So in this session, we have seen about the mixture. And mixture is nothing but if two or more substances are pure substances are forming a composition, that itself is called as a mixture. And mixture composition is variable, and it may be in any ratio. Components may be in any ratio. And mixtures further classify into the homogeneous. If all the components are uniformly distributed, thoroughly mixed, homogeneous. If the components are not uniformly mixed, then it is known as heterogeneous mixtures. We have seen some examples also. And we have seen some methods, physical methods to separate the components of the mixtures. Yeah. So I end the session. Let us see some more points in the next lecture. If you like the video, please subscribe the channel and encourage it. It's a free educational channel for the aspirants of IIT and NEET. Thank you very much.